Now, in this video, we seek to explain the general expression used to find the slope of a curve at a given point, or the gradient of the tangent to the curve at a given point. Now, let's consider 2 points A and B on the curve, which are close, very close to each other. By a small increment in the x-axis and in the y-axis. Now, the gradient of the curve at point B is different from the gradient of the curve at point A. And so at different points on this curve, different gradients would be the case. Now, let's consider the chord AB. And let us consider that the curve is defined by the function f of x. And if the position on the x-axis at this point is given by x, then the outcome of the function at this point on the y-axis is given by, say, y. And if the position on the x-axis at this point is given by x plus dx, then the outcome of the function at the point B would be given by y plus dy. So at this point on the y-axis, the outcome of the function will be y plus dy. It will then mean that the coordinates of A is given by x, y, and the coordinates of B is given by So it will mean that at the point B, the outcome of the function will be given by Now, let this small increment in the x-axis, the x, be indicated as h. So the gradient of the chord is given by, now from the diagram, dy dx is given by f of x plus dx minus f of x. So we can represent dy as and by that, the gradient of the chord can be represented by Now, if we are to assume that the point A is fixed and the small increment dx reduces, in other words, h decreases, then it is going to affect the gradient of the chord AB. So as the x further decreases and h approaches 0, this expression can be represented as such, as limiting the x approach 0. The gradient of the chord So it means that as the small increment dx reduces in value and approaches 0, the gradient of the chord approaches the gradient of the tangent to the curve at the point A. And so in other words, the gradient of the curve at the point A is defined by and in the functional notation can be expressed as that. And this is what is called differentiation from first principle. So we can only determine the gradient of the curve at a particular point, say A or B. And to do that, we can use this formula, which is the derivative of a function using limits. So in an exercise, let's determine the derivative of a function from first principles. So let's try our hands on this exercise. We do know from the first principles, the derivative of a function can be determined using this formula. So from this function, f of x is given by, and that f of x plus h would be so here we replace s plus h wherever x is. So let's substitute these expressions into this formula. So here, let's work out the numerator and simplify it. Then we can introduce the denominator. So we're going to have f of x is this. And so the expression over here represents the numerator. We want to simplify the numerator first. So in this expression over here, we're going to have as our common denominator x plus h. So we're going to have and here we're going to have as our common denominator x over here. So we're going to have this. So let's go ahead and simplify by expanding. So now here we're going to have as our common denominator the product of x and x plus h. So we're going to have so if I'm to expand, we're going to have something like so this cancels this out. 6s squared h and minus 3s squared h. We're going to be left with 3s squared h. So this and this goes off. We have this here. The s goes off. Then we have minus h x into brackets x plus h. So let's replace this expression with the numerator. So we're going to have So this is what we had for the numerator. And now we bring in the denominator here. So in simplifying, we're going to get, now from the numerator, we can factorize out h. So we're going to get simplifying. This h cancels out. So we're going to be left with so now here, let's limit h approach 0. So this expression can be rewritten as so this cancels this, and we're going to have the derivative as, so the derivative of this expression over here using the first principle is given by 3 minus 1 over x squared. So this is the end of my video. Thank you very much for watching, but keep watching.